Hello, my name is Bogdan Kostov, and today I'm going to share a little bit of experience of trying to generate data, synthetic data, specifically synthetic data for event reports for a software evaluation scenario. So I will start a little bit in general for data generating, just to have some context. So why generating data? Well, there is several reasons, but the most important is probably the fact that data is scarce, and there's different reasons for that. For example, it's hard to obtain. There's some legal issues that needs to be resolved, or maybe the data doesn't even exist because the system is going to be a part of a bigger system which should generate more data. So yeah, the data might not be available. Then obviously there is these other issues which are privacy and security. So essentially we don't want, maybe companies don't want to share information about people like name, addresses, email, phone numbers. And security reasons is maybe companies want to avoid sharing confidential information or maybe even leaking unauthorized access. So what are some data generation use case, at least some categories? Well, data generation is used in software testing. Um, I mean, in this case, automated testing, but it also can be used for manual testing. So that's the evaluation, and not just for testing purposes, but maybe for demonstrating the what the software can do. So the use cases of the software. Uh, and recently, it's very popular to generate data for machine learning and AI. So what kind of data can be generated? Basically everything. So from text to structured data, images, audio, and video. So that's all kinds of ways to generate this kind of data. But in our talk, or what I was focusing on, is generating structured data, specifically tables. But I guess it could be extended to JSON or XML, but uh, we will be talking about tables here. So what are some ways to generate data, specifically structured data? Is if we are really interested only in the structure of the data, let's say we want a table with 5 columns, then we can, and we are not really interested in what's in the columns, then we can use just some random generator, generate some values, and that's it. So that's a pretty simple way. If we want a little bit more representative data, so we can use a rule-based method where, let's say, manually users provide rules, which could be from simple rules like defining the types of the columns. So maybe one column is of date time, another is some categorical column, and so on, but also relationships between columns. And the most sophisticated way, but also which requires sample data, is to use generative models and machine learning to kind of fit a model according to the data, and then use that model to generate new data. But that obviously requires an existing sample data. So if we have sample data, then that method is superior to the rule-based method because it will generate a lot more realistic data. I guess it is reasonable to consider another point, which is using an LLM, but I didn't include it here because I guess it could be a part of the generative models, as well as I'm not quite sure how to control it enough for the use case that I have. So that's why I'm not going to talk about LLMs. So when I was trying to do some data generation, I was looking for some tools to help me do the job because doing that from scratch is not really easy. So what tools did I found? So by the way, all of those here listed are Python libraries. So the first one, Faker, is, from what I can tell, is very useful for generating common data fields like names, addresses, and other things that we are used to seeing in the data. So if we generate names, maybe it will generate my name at some point. So the other one, which I decided to use, is the Memesis. And this library allows to build rule-based schema and to generate code data according to those rules. Then is the synthetic data vault. This library also provides the functionality of Memesis, more or less. I didn't make some extensive comparison, but this SDV library allows to, it has this part where you can fit sample data to some generative model and generate data like that. It also has the capacity to generate data using rules. However, this part of the library is paid, so I decided not to use this library. And finally, it's an interesting library, PlayPy, which also generates data based on rules. And the rules are specified in a YAML configuration file. It seems really nice. You can run it on the command line, also in code. However, it is quite old and it's not being maintained. There are some forks, but I decided to go with Memesis, which is only code based. There is no like a configuration file, but it's something that is maintained. So about the specific case that I am trying to generate data for is for the evaluation of a dashboard application. So what is this dashboard application? Well, it's kind of a dashboard, which is like a list or collection of indicators which show the frequency of occurrences in a high risk environment. So here in this screenshot, you can see a list of indicators, and what we see is the occurrences per month in some range, some interval, which is 1 year, I guess, at this point, at this particular diagram. And the blue line is the number of occurrences, and then we have a red line and a green line, which shows what is the accepted level of these occurrences. So we can see here this indicator 9 has reached the green line, so it's like between the green line and the red line, so that's why it's yellow. Okay, so that's kind of what the main purpose of the dashboard application is, to show for different occurrences these kind of indicators. There's around 50 indicators, which are separated in different views because they're not on the same level, let's say. So what we can separate the indicators in based on the occurrence type that they are following. So there is the incidents, which uh, are so if something happens and it's some loss, but then there is like inspection and maybe safety briefing. So these are more like proactive activities, which are also shown in the indicators. So what about these indicators is other interesting is that there are relationships among the indicators. So for example, we can have indicators which show some part of relationship. So let's say we have an aircraft damage, but we can also break down the aircraft damage according to aircraft damage by another aircraft or by some vehicle or by infrastructure or by another by a person. So that's what I mean here by uh, part. And there is also contributes to or causes relationship, which is because these indicators here cause or contribute to the damage. So if these things happen more often, then perhaps we are going to increase the number of aircraft damage. So basically, there are this contributes relationship is separating indicators kind of on uh, proactive and reactive. So the reactive indicators is if, when the incident occurs, and then there is something that causes it, which is the proactive indicator. So maybe we are following some discrepancies uh, during procedures, uh, unacceptable states of equipment and vehicles, and so on, uh, and monitor that, which might contribute to more aircraft damage. So this is kind of what is interesting to be tested in the application. So to generate the data, I need to somehow define some schema. So there is a lot of different uh, data sets that we have that to test the application. However, in general, there is this kind of fields. So there is a date time of the occurrence, then there is some sort of occurrence categorization. So that could be one more. So it could be categorized as an incident or inspection finding, let's say. Uh, and then there is a specific categorization, which could be like for incident, a collision, or for inspection finding, unsatisfactory equipment state. So, but there could be more categories here. Then there is the participants. The participants, depending again on the type of the occurrence. So it could be the subject. Let's say for the inspection, if there is an inspection, there is an equipment or a vehicle that is being inspected. So that would be the subject. But in case, let's say, of some sort of collision, then that could be the participants, vehicle one and vehicle two. Sorry. Jumped ahead. And then the last field that is relevant is the location. Now the location could be, there could be different types of locations. So that could be a named place, like a particular address, or maybe if we're on the airport, a particular runway, taxiway, or aircraft stand. But it could also be some sort of coordinates like GPS. So these are kind of the fields that we would like to generate. So if we have sample data, this is kind of the code that we can use to generate using a model fitted on the sample data with the synthetic data vault. So first of all, we need to initialize the synthesizer which is basically a type of model that we want to fit, and we provide it with the metadata. And the metadata is shown here on the right, what it could look like, for example, for um, some data set that has these fields, so an ID, type of incident, timestamp, location, and the participants, 1 and 2. So we create the synthesizer, and then we fit it to the real data, and then generate 100 rows. So that's pretty straightforward. However, it requires this sample data. And so we have a case for the sample data, but we also have where we don't have sample data, so we need to use some rule-based data generation. So for this, I'm using Nemesis. And so this is the basic idea, similar schema, how to generate, how to define the rules and generate some data using Nemesis. Sorry, Nemesis. So first we import the required libraries and initialize the field and the field set variables, which are used to define the columns, to define the rules for the columns. And here we are defining just the rules for the individual types of the columns. And so this is the schema. The schema has to be a lambda function or a function. It doesn't have to be a lambda, but it has to be callable. And it's because it's going to be called each time. So if it's not callable, if it's just a structure, then we're going to generate the same row each time. So it has to be callable, and these function field and field set will generate a new time each time a new value. And we can set the seed, and here we have some seed set up. So that means that each time we run the generator with this seed, we should get the same result for that particular setup. Okay, so what are the fields? We have primary key, we have the type of the incident. Oops. Then we have the location, the timestamp, and the participants. Okay, sorry, everything's fine. And then we use this schema to generate 10 rows. And that will be generated randomly, right? There is no fitting of sample data. So to actually do that, I created some custom fields, which is the incident type, the places, and the vehicle type. And this is how this is done. So we have some functions. Each function is defined for the particular field type. So the incident type, it has a bunch of types, a random choice, and I am giving it some weights. So there is a weight for each of these vehicle types. Sorry, incident types. The same for the vehicle types and the places. So there is particular use cases that we want to create, which this Nemesis library is not really fitted to do. So I have to somehow work around this and make it work. And that is, I want to create these reports with certain frequency so that I can change the frequency so that we can demonstrate the data in the data that we have some periods where the indicator is doing okay, and then at some periods the indicator is being breached. So the red line is being breached. And that's just for one particular indicator, but it will be also nice to have to demonstrate this functionality between causality between indicators, is to have proactive indicator going from low frequencies to higher frequencies over the red line, and then with some delay, it's dependent, or the reactive indicator, which depends on it, to go up as well. There are some other rules that needs to be considered. So, for example, there is some similar cases to these two, but let's say we're in a parking lot and there are two cars, and two cars cannot park in the same place. That's the first bullet. And the second one is, if there is, let's say, a collision, the participants cannot be the same vehicle. It has to be different vehicles. So that's it. Thank you. And I'm happy to answer any questions.
Okay, thank you, Bogdan. I would like to ask, so there is some, if I understood it correctly, you taught the model from the real data, right? Or
No,
did I
no, there are two.
misinterpret it?
No, there are two methods.
In one case, the first one. Can you show the slide?
Yes. So in this case, we can do that. Yes, kind of. If we have sufficient amount of that data, there are different synthesizers. One is supposed to be for sparse data. So yeah, but it could be used for, I guess, for this purpose, which would be for the reactive indicators. So basically,
Okay.
near misses and stuff like that.
Okay, and how it is ensured that some leaks are not occurring or something? Does it do they somehow solve this or?
Sorry, I thought I had it. Yes, we can put specific columns which would be overwritten with new data. So they won't use the data from, let's say, emails and stuff like that. But you specify the column. I don't think I have it here. If you want, I can look for an example in the documentation, but you can specify it in the metadata, I believe.
I mean, I'm trying to think of the training set that contains, in general, some data that you do not want to leak, but you want to train on that.
Yeah,
Is
that
there
should
any?
be, if I understand correctly, I would definitely, if we start using the real data on in this library, then I will definitely check that this fitting is local. I believe it's local, but I will double check that. So it should be local. It should be something that you do on your PC. It's not like connecting to some service.
Okay, thanks.
Okay, Bogdan, I also have some questions. It was interesting presentation, overall. I have some questions. How about if you are, yes, this synthetic data world, were you testing generating data in various languages? Or the question is, can it handle
Yes.
Czech?
Yeah. I don't know if it can handle Czech, but both libraries have locales, and you can set them to different locales. So both this SDV and Memesis. I think this specifically synthetic data vault is based uses to generate data this other library that I mentioned, Faker, which also has these. Sorry, it's jumping. It has locales, so you can generate names, dates, times, currency, and stuff like that with the particular locale. But if it has check, I have to check. I'm not sure.
Yeah. And then okay, you can specify here the structure of the data. So I guess that you can you had it on different slides so that you are creating some metadata or some schema of the table you want to generate. And here you are just saying that you have some types. So you have IDs, date times, I suppose strings, numbers, also regex formats. What is the precision here of the generation? It's like from the view of the structure, if you say these rules and you give him some sample data, so it generates data and you can be 100% sure that it fits the structure you have set up.
It will definitely fit this schema. So the structure will be fit. If you mean if there are going to be missing values, you can make it miss some values. So you can make it messy, if that's what you mean. But the other thing is you can, in this particular library, because you generate according to a sample, you can test the generated sample. Sorry, let's say you have the real data and then you generate synthetic data. So then you can compare them and see how statistically how different they are.
Yeah, so
you have this kind of, the library provides this kind of quality checking, which yes, it's a good point. In general, when you generate the data, you want to you would like to also check how does the data look and if it fits some.
yeah, definitely this is for some further discussion. I have some other notes written here for that. For example, can I generate like willingly wrong data? I can just test it for some validation, for example. So I want to have some data and I want to have willingly some mistakes there. So I will test that the validator is going on all right. Or I was thinking also about if you have some code list values. So I
Yes.
get it that you expect that all the values will come from some code list, and what if the code list isn't there? Or so can I just specify it here, or I can have some conditionally dependent values on some other value, other attribute specific value, and this kind of stuff. So this is also doable in this approach.
So regarding code values, I think, if I remember correctly, I think almost 100% certain that you can specify a code value for a field. So not only that it's fitted from the real data, but you also can say, well, the real data maybe has not all the values, so you can use also
Yeah.
these other ones.
I have some examples in my head. Is, for example, you can have generated metadata, some simple metadata for some records, and you can have the record type, which is dataset or service. And if it is dataset, it will have a different code list for some other values than if the type is dataset or the type is service. This kind of stuff.
So you mean for validation?
No, I mean for generating data. So, for example, I want to generate, I don't know, 100 metadata records, and some of them
Okay.
will be metadata of data sets, and some of them will be metadata of services, for example. And then I will have, for example, some protocol will how to get to the data. And for the data sets, the values will be different than for services.
Yeah, so
this is like the
okay, so
conditional
yes,
generation. Yeah.
yes, I think that's possible, but I'm not sure. I don't remember seeing an example of that, but I believe it is somehow possible.
Yeah. And in the
Uh,
presentation, the whole presentation, you're presenting the settings and the metadata models and so on. And I haven't seen the generated outputs. Have you looked into that, or can you show us something like that? What is in the end the output of the generator?
well, I don't have this one right now, so this is uh, generating. You can both of these libraries can output CSV. So that was my goal, and they can work with CSV. This Memesis will generate by default the JSON, but then you can convert it to CSV.
And we're looking at the data. Why haven't you shown us the outputs?
Well, I don't want to show it because it's for the airport, and this is just an example. I didn't run it.
Yeah. Okay. So you didn't run it, you just shown it, and okay. Okay, thanks.
But just to, I think there was one more thing you asked and I didn't mention is that you can also change the probability of the distribution of the values, the categorical values. So, or even like if it's a number, you can change the distribution type for this fitted model. So you can make it more. You can customize it. It's not just that you fit it on the data. You can do some customization after you fit it on the data.
Okay. And I have one more note here that you were showing some evaluation based on the frequency, and I didn't understand what is the frequency here.
Okay, so
Yeah, this one.
so this is basically what are the indicators. So or at least some of them, or most of them, they're counting the number of occurrences, and in this case, they're counting the number of occurrences in each month in 1 year. And um,
And this is from the original
this
data,
is
or
this is no, this is just an example, and this is the frequency. And here in the first half, let's say, we have it ordered very strangely, as you can see. Uh, so I guess it's from last second half of 2004 until the first half of 2005. So this is basically before that. So we have the frequency of these incidents were above the red line, and then afterwards they fell down. So that's something, some of the scenarios that we would like to have to generate. And this is something that it's not really supported directly in those libraries. So it has to be done outside in some other way.
and the inputs here, this is just the sample, but if you will be doing this like for the real life example for generation of the data, then this is the input or this is the output?
Well, this is the requirement. So I would like to have
So you
some
specify the
data.
requirements, so for the generated data, the occurrences will be distributed in this way.
Yes. So there's basically how I see this happening is I will have to define for what time I would like to generate. So I would like to generate for the second half of 2004 with a certain frequency, and then I would have to generate another data set for the first half of 2025 with a lower frequency, and that's the only way I can um, understand how this could be done. So how to specify the frequency is either I can just, because I have 6 months, I can just say, well, in 6 months, I will adjust the frequency for the 6 months to be higher and then lower. But there is more sophisticated ways to do that.
Yeah, okay, I understand. Thank you.